Welcome back to another Forge College Explainer. So, if you hung out with us for the last session on deployment pipeline design for Anchor projects, you know we sketched out a pretty brilliant high-level blueprint. We separated our build, test, and deploy stages to get everything perfectly organized, right? But look, a blueprint is just ink on paper until you actually start bolting the machinery to the factory floor. So today, we're going to recap our previous pipeline design and do a complete factory retrofit for your CI/CD workflow. We're going to adopt our continuous integration and delivery so that all your artifacts flow seamlessly through Git commits, automated tests, and staged deployments. And the best part? We're going to do this without breaking any of your existing expectations or, making your DevOps engineer rage quit. It's going to be highly practical, heavily automated, and honestly, surprisingly fun. Let's jump right in. Okay, here is the agenda we've drawn up for today's factory retrofit. First up, we've got the factory retrofit. Number 2, runners, caching, and containers. Third, securing secrets and key pairs. Then fourth, cross-ecosystem testing checklists. Fifth is safe deployment to staging. And finally, we'll wrap it all up with our conclusion and next steps. Let's kick things off with Section 1, the factory retrofit. To really put things into perspective here, imagine we are taking your existing Hardhat or Foundry environment and completely upgrading it to a reproducible Anchor environment, all without breaking your old machines. In your old EVM factory, your CI pipeline probably cranked out Solidity contracts with no problem. But now we're introducing Rust and Solana. We absolutely can't just toss out the old tests, but we also can't let these new, much heavier Rust builds clog up our assembly line. So we need a containerized pipeline that can gracefully handle both your EVM checks and your new SVM programs whenever you push, open a pull request, or merge. Now, to draft these new blueprints, we're going to use this super simple 3-step iteration cycle with an AI site manager until we literally get a green light on our staging branch. Listen, you don't have to write this massive new GitHub Actions workflow totally from scratch. You just start by feeding your current CI file to the AI and asking it to generate a baseline workflow. Then you execute it. Let me be real with you, it's probably going to fail the first time. Maybe it misses a Rust toolchain version or an Anchor CLI path, and that is totally fine. You just capture those failing logs, feed them right back to the AI, and ask it to adjust. You repeat this loop, keeping your commits super small, and treat those failing jobs as helpful little tutoring signals until the whole pipeline goes green. All right, moving right along to the heavy machinery in Section 2, runners, caching, and containers. So artifact caching is absolutely crucial here. It stops our heavy Rust builds from grinding the entire continuous integration assembly line to a complete halt. Look, Rust compilation is infamously thorough, right? Which means it can be painfully slow. If your pipeline tries to rebuild the entire workspace from scratch on every single commit, your developers are going to be waiting around, drinking way too much coffee, or literally contemplating a career change. By storing those compiled .so artifacts in a cache layer, we basically treat the heavy Rust build steps as shareable across our runners. It's a complete game changer for your CI performance. To make sure that our local dev, CI, and staging environments are all running the exact same tool chains, we need our AI assistant to generate these specific components. You're going to need a primary orchestrator, like a ci-anchor.yaml file. You also need a Docker file, so your containerized environments are perfectly reproducible. Seriously, no more "well, it works on my machine" excuses. And finally, you'll need a tiny script to securely unwrap your key pairs. Requesting these exact artifacts gives you a rock-solid, fully testable foundation. Which brings us to Section 3, and arguably the most dangerous part of the factory, securing secrets and key pairs. I really cannot stress this point enough. Printing your secrets in the CI logs is basically the same as donating your crypto wallet to the entire internet, so we have to treat them with extreme caution. As the quote says, treat your key pairs like radioactive material. Unwrap them securely, use them quickly, and obliterate them immediately. We're operating in Web3 here, meaning real, actual value is attached to these keys. If your CI system carelessly echoes a base64 string or prints the JSON array of your key pair right into the GitHub Actions log, any random bot scraping the web is going to drain your resources in seconds. We've got to be meticulous. So the crucial takeaway is that you must follow these exact steps to unwrap and then destroy your keys securely during the CI run. We definitely don't want to fund a hacker's early retirement. First up, decode your base64 encrypted secret. Next, write it to a temporary ephemeral file, something like /tmp/id JSON. Then export your Solana environment variables straight to that file. Go ahead and do your deployment. And finally, and please pay attention because this is the most important part, use a secure deletion command like shred to obliterate that file instantly. And never, ever print those contents straight to your CI logs.
Let's head over to Section 4, Cross-Ecosystem Testing Checklists.
Here is where we use lightweight shims to make absolutely sure your existing Foundry and Hardhat tests can actually talk to the new Anchor workspace tests running in our container. Since we're right in the middle of a migration, you probably have a massive suite of JavaScript or Solidity tests lying around. A shim is basically just a tiny Node.js helper script that bridges that gap. It runs your old tests, looks at the results, and then formats them into something that our brand new Anchor pipeline can actually understand and document. And the output of that translation process is this living JSON compatibility checklist. Instead of just failing your build in some cryptic, confusing way, our shims generate this awesome checklist that automatically flags any unresolved items for your migration plan. It gives every single check a unique ID, a description, and a status, like OK, warning, or fail. This file then gets uploaded as a neat little artifact at the end of your CI run. It essentially turns into a living, breathing to-do list, telling your reviewers exactly what manual interventions or automated fixes are still needed before you can call the migration completely done. All right, almost at the finish line. Section 5, Safe Deployment to Staging. Before we even think about shipping anything, our CI run has to meet these incredibly strict success criteria. This proves our whole retrofit actually works, from the initial build all the way down to deployment. We're looking for these exact signals. First, the Rust build must end with a total success status, totally green. Second, integration tests absolutely must report 0 failures. Third, we want the deploy step to show a deployment manifest, proving it actually happened. But, and I can't emphasize this enough, with absolutely 0 private keys printed to the log. And finally, we need our smoke test to come back positive. This perfectly illustrates our ultimate safety net. We only ever deploy to staging when all tests pass. And it requires 2 vital things, a reversible step and a quick smoke test immediately after sending the new code out into the wild. A smoke test is just a super fast automated check, kind of like pinging the newly deployed program, just to ensure it gives us a basic RPC response. It just proves the deployment isn't sitting there broken. And by making sure you have a reversible step, if that smoke test does happen to fail, you can just easily roll back to the previous stable state without causing a massive panic across your entire staging environment. And that brings us to Section 6, Conclusion and Next Steps. Let's wrap this up with our key retrofit takeaways. Remember to keep your commits super focused. You've got to reuse your heavy Rust caches so your pipeline stays lightning fast. Always obliterate your ephemeral key pairs instantly so your vault stays secure. Bridge those ecosystems using your small adapter scripts or shims, and package a living compatibility checklist artifact to guide your progress. If you stick to these core principles, bridging that gap between Hardhat and Anchor transforms from a chaotic guessing game into a highly structured, totally manageable process. So here's the big question. Is your CI pipeline officially Anchor ready for the migration capstone? Once that CI run finishes totally green and your checklist is uploaded, you are absolutely ready for the full migration audit. You've built yourself a robust, secure, and blazing fast deployment pipeline. But remember, automation is literally only as smart as the parameters you set for it. If your shiny new factory can deploy a flawless program in seconds, what happens when it deploys a deeply flawed one just as fast? Definitely something to chew on as you refine those safety nets. Thank you so much for joining me for this Forge College Explainer. Make sure you head over to forge.college to dive even deeper into this and tons of other amazing Web3 topics. Catch you in the next one.